Welcome back to Topic 6 for Algebra 2, Relations and Functions. In Part 3, we're going to learn about evaluating functions, using relation machines, and determining the relationship between an input and an output. In our first example here, we're asked to find the relationship, or the rule, for how we get from x to f of x, or x to y, using the table. So we're asked to fill in the missing boxes. On the x row, this is our input, and f of x is our output. So in our row of x, we have 9, 1, 100, 4, 49, 0, 25, and 20. In our outputs, we have 1, 7, 4, and 5. So we want to especially focus on these pairings where we have both the input and the output. So that would be 1 and 1, 49 and 7, and 25 and 5. Now this relationship rule has to apply for all of our inputs to our outputs. So what can we do to our input to get an output? Well, from 1 to 1, that doesn't change very much, so it is not super helpful. Let's move on to the next example. 49 to 7, well, we can divide by 7, and that gives us 7. But then if we divide 25 by 7, that doesn't give us 5. In this case, what we need to do is take the square root. So the square root of our x value will give you our f of x, or our y value. So we can go through and fill these all in. The square root of 9 is 3. The square root of 100 is 10. Square root of 4 is 2. 4 squared, so if we want to go backwards, would be 16. The square root of 0 is 0. And the square root of 20 is the square root of 20, which can be broken down into 4 times 5, or the square root of 4 times the square root of 5. And since we know the square root of 4 is 2, this can be 2 root 5, or 2 times the square root of 5. Now notice how all of these outputs are all positive. So we're only dealing with the positive values. We could take the square root of 49 and take the square root of 49 would give us positive 7, but also negative 7. So we're only focusing on the positive values here. Looking at some other examples, we're going to deal more with relation machines. So learning how to plug in a value in for x into a relation and identify the output. Now some of our examples will have inputs and outputs, but others will not. So we'll need to keep an eye out for that. In our first example here, we have x equals negative 3, and we're plugging it into the relation machine, f of x equals negative 2x plus 4. So we want to figure out what our output would be. If we plug in f of negative 3 equals negative 2 times negative 3, because we're plugging in for x, plus 4. When we simplify this, we get negative 2 times negative 3 gives us positive 6 plus 4, and that gives us 10. So f of negative 3 is positive 10. When we plug in negative 2 for x, we have f of negative 2 equals the square root of negative 2 plus 3. Simplify under our radical here. Negative 2 plus 3 gives us 1. The square root of 1 is both positive 1 and negative 1. Note here how this is not a function. And why is that? Well, we have our negative 2, our input, is going to positive 1, and negative 2 can also go to negative 1. So if we were to graph this, it would fail the vertical line test. In order for this to be a function, we would only need to have either the positive side or the negative side. So we need to specify that. We will learn more about that later in Algebra 2. For C, we have x equals 5. We're plugging it into f of x equals x cubed. So f of 5 gives us 5 cubed, which is 5 times 5 times 5, or 125, which is what f of 5 equals. For 26, this is slide 26, problem D, we have x equals negative 2. We're going to plug that into f of x equals the square root of x plus 1, so it has a vertical translation up of 1 unit. F of negative 2, we're going to take the square root of negative 2 and then add 1 to it. However, here we actually have an error. you cannot take the square root of a negative number. So some students often associate this with, if there's an error, I'll just write 0. That is not the same thing. So we can't just equate an error to 0 and then add that 1 and have our final answer be 1. For this problem, we have no possible output. Letter E, we're plugging in x equals 2 into our function. So f of 2 equals 2 plus 3 over 2 times 2 minus 5. 2 plus 3 is 5. 2 times 2 is 4 minus 5. We get 5 over negative 1 or negative 5. So f of 2 is negative 5. Now in for f, we have to find our input. So we don't know what value we're plugging in for x, but we do know our final output. We can set this up as x squared minus 1 equals 99 and solve for x. So we can add 1 to both sides and get x squared equals 100. So what number times itself will get it 100? Well, we know x could equal positive 10 and negative 10. Now this problem is a function. Here we have a value of x, let's say positive 10 goes to 99, and negative 10 goes to 99. So it would still pass the vertical line test. Here we're also trying to find the possible input for x if we're plugging into the absolute value. So we want to see what number can we plug into the absolute value so that we get an output of negative 3. Now we can hear there is actually no possible input. And that's because we cannot have an absolute value equal a negative number. Moving on to letter H, we have x equals negative 4. We're going to plug that in for x. So negative 4, f of negative 4 equals negative 4 minus 2. Simplify in our parentheses, and we have the absolute value of negative 6. Now this is something different. If we plug in a negative number inside of our absolute value, that can still give us a positive number in the end. That can still work. However, an absolute value can never equal a negative number. If we take the absolute value of a negative number, that's just saying how far away it is from 0. So negative 6 from 0 is 6 units. So that is our answer. So f of negative 4 equals 6. Last but not least, we're plugging in x equals negative 4 into the absolute value of x minus 2. So f of negative 4 equals the absolute value of negative 4 minus 2. The absolute value of negative 4 is positive 4, subtract 2. So f of negative 4 is positive 2. And that was topic 6 for Algebra 2, part 3 on relations and functions. Thank you for watching.